Welcome to today's lecture on industrial hydraulics and pneumatics. Now, today's lecture will be on pneumatic system and components, and this will be introduction to that, and the particular topic will be air preparation, compressor and accessories. Now, contrary to hydraulic system, pneumatic systems use pressurized compressible fluids. This means that in case of oil hydraulics, the fluid is compressible and incompressible, and a pressurized fluid inside a conduit acts as a elastic body. Maybe it is like an solid member. Therefore, in that case, particularly where with closed circuit, there is no change in pressure once it is the fluid is trapped. Of course, that depends on the load required we are moving, but in case of this compressible fluids, air or gas, what happens? The fluid after utilization, it is exhaust to the nature, and in that way pressure of the fluid reduces. So, for the constant pressure system, it is not that much suitable. Also, it is not suitable for very high power. So, but for the small applications, small power applications, tools and others, you will find this pneumatic system is very useful, and air is free of cost. You are getting it free of cost. Only thing you have to prepare the air for utilizing into a system. Now, although other gases are used, but air is the most common compressible fluid. Although some gases are also used in pneumatic drives, especially where the gas itself is one of the product or byproduct where the system is being used. However, air is the environment friendly, cheap, safe, readily available fluid media for pneumatic applications. For general purpose actuator drives manageable with low pressure, usually 2 megapascal. 2 megapascal means it is 20 kg per centimeter squares, and you can see just a little above the absolute pressure. Pneumatic system is preferred over hydraulic system where pressure may be as high as 80 megapascals. This means that in hydraulic system we can go up to 80 megapascal, but in normal case, as you know that in oil hydraulics 20 to 25 megapascal is very common, 80 megapascal is very special applications, but it is possible there. However, position or actuation at controlled velocity is not achievable with compressible fluids. This is a drawbacks with compressible fluids. If you would like to control the position control or the velocity control, then it is very difficult to achieve. For a small magnitude, small zone, it is possible. Relatively larger zone, larger range, where the hydraulic fluid will be more useful. Pneumatic application in such areas are rare, and where hydraulic oil cannot be used due to environment reason. Actually, we had in some cases it is compromised where the hydraulic oil cannot be used due to environmental reasons. So, better to go for pneumatic applications. Say for example, in case of food processing industry. Also, less accurate performance is acceptable. In pneumatic system, compressors, typically the vane, lobe, screw or cylindrical piston type positive displacement machines are used to compress and store the air. Now, here again I would like to mention that in case of pneumatics or the compressible fluid, the machines, the hydrostatic units are used, that is pump and motor, those are in nature positive displacement. This means that their volume displacement ideally will be equal to their geometric displacement. It is not like hydrokinetic machines. For example, a blower, if we consider a blower, it is not a positive displacement machine, unless it is a positive displacement machine is being used for a blower. So, I think you understand what is positive displacement, that if you calculate the geometric volume displacement, ideally that will displace the same amount of fluid. Now, in case of compressible fluid, definitely this volume is being compressed. That means, when the pressure is increasing, that volume is being compressed. So, by the pump, that much amount of is being pumped, whereas it might be of higher pressure, and then it is going into the reservoir, that means collector, and gradually you will find that if you ask that what is the volume of air inside the reservoir, the answer is that what is the geometric volume of the reservoir, that is the volume at any point. Only thing, pressure is gradually being increased as you running the compressor. In case of oil hydraulics, it is not that. This means that in the conduit, obviously always you have to say volume is equal to that amount of volume, but you can say your positive displacement machine also delivering the same amount of volume. In case of the air, it is not, or gases. The compressed and stored air or gas used in operating pneumatic devices whenever required by tapping in a regulated manner the air from storage vessel tank, normally attached to an or integral with the compressor. This means that it is not that you are directly pumping this air to the system. In case of hydraulic system, most of the cases you will find that there is no reservoir in between. If you consider at all there is a reservoir in between, that you may consider the accumulator, very small reservoir. But in case of pneumatic system, there will be always a reservoir. That means, first the air is stored in a reservoir or receiver, and then the air is used for the system. You can simply tap the air with the help of a regulator and can use it. Usually compressor is stopped at a set higher pressure than maximum operating pressure. Say for example, you are using in your pneumatic systems in your workshop or maybe industry, for machines maximum is 1.5 megapascal. Maybe you are storing that air inside the reservoir at 2 megapascal. It automatically starts again when the stored air pressure reaches a minimum set value. This means that say for the reservoir 2 megapascal is the upper limit. So, when the pressure inside this reservoir will reach at 2 megapascal, it will be automatically stopped, and probably it will start again the minimum pressure what you need for the operations. Say for example, it might be 1 megapascals or might be 0.7 megapascal, whereas maximum for some devices is 1.5. So, when it will reach that 0.75 or 1 megapascal, it will start. But one thing we should remember, that if we had to use that instrument or device which requires 1.5 megapascal, then we have to set the lower pressure as 1.5 megapascal. So, then range will be 1.5 and 2 megapascal, and also usually there will be a time set, otherwise the compressor will run always. So, that is a design criteria that you have to design in a system. Suppose you are using this, always it is 1.5 megapascal and very continuous consumption is there, probably you have to set the compressor reservoir side in such a way at least your compressor can be stopped for 5 minutes while it is running. Otherwise, question of heat generation and other problems are there. Usually from a centralized store, air is supplied to various locations of an entire industrial plant. It might be single reservoir, it might be multiple, usually not more than 2 reservoirs are used to supply the plant. If the plant is very big, sometimes it is more than 1 reservoir is used. After filtering and before the end applications, a fine mist of lubricant is mixed to the air to prevent wear in the moving components. Now, usually if you find that air operated devices, say for example, air operated screwdriver. So, you just put, say if you have observed in automobile industry, they had to tight the screw maybe in a line, in a assembly line, they have to tight a screw 100 screw per minute, say just for an example. In that case, every screw driving by the screwdriver is not possible. You will find the pneumatic screwdriver is there, and it is set like that for the screwdriver device. When the maximum torque is reached, it will automatically slip. So, now in that case, that is connected with a pneumatic systems. Now, usually this moving component inside, definitely there is moving component, there is no separate lubricant inside. So, with the air you have to mix that lubricant, normally with the air, not with the other gas and other things. In case of gas also, you have to take care of that, what type of lubricant you can mix. In case of air, ordinary lubricant can be mixed, but before that your air should be all dust free and it should be dry. That means, no moisture is allowed within this air. So, after filtration or such preparations, again you have to mix with oil, that is important. This is required to lubricate the moving components. Air dryer is also used to eliminate moisture from air. So, as I have told that you have to use an air dryer. A muffler is put at the exhaust to reduce noise. Now, muffler means the silencer is usually used at the exhaust point. Okay. Now, when you are using a system, then the device you are driving. So, it might be after that application there should have muffler. That means, muffler in some cases you will find is an integral component or of the pneumatic device which you are using, but there is also inline muffler just to reduce the noise level. When the air is flowing through these components, there will be noise. You know it, that when air blows through, even if in nature also when air blows you can hear the sound. So, to reduce such noise there will be muffler or which is called silencer. Now, next slide we will look into a a pneumatic system. I think that you cannot read this not that clear, but I would say that here there is a, this is the compressor unit. This compressor unit is having this is the driving unit, and then maybe filter, then cooler, and after then this is the main reservoir, and here there is a dryer. At that point there is a dryer, and if we look into this, what we find, we have two parallel system connected to the same line. As I told, in case of, if you find that air is being utilized in such a way, if you use single compressor, then it will run, it has to run for, I mean, continuously. That is not permitted to look into the life of the compressor, because during such process huge air is generated. This is due to the molecular action within this air. Now, one can have one compressor and maybe two reservoirs, or might be there is a big reservoir and two compressor. This is usually safe system to use two compressor rather than manipulating something with the reservoir. And then it is also shown here, say these are the two work point, but usually there will be huge I mean many work point. Now, these tools are called pneumatic tools, and here this is the regulator, filter and lubricator are used at a different point. Say each and every, before each and every pneumatic tools you will find a filter, regulator and lubricator is being used. So, this is a very schematic and very general system for a pneumatic. There will be a pipeline throughout the industry. Now, in preparation of usable pressurized compressible fluids, we need following major components. One is that definitely a compressor. Compressor is nothing but a pump which is pumping the air or gas. A receiver or a reservoir tank, starting unloader and controller. This is very important, we will come to that what it is. Then we need filters. Now, this filters is not again the suction strainer, there will be there. After the compression we need a filter, online filter to make the air dust free. Then we need definitely a regulator and valves. We need a lubricator as mentioned, mufflers and silencer. After cooler, we need a, after cooler means usually the air before entering into the machine we need to cool it, because the air we exhaust into nature. So, we do not need after cooling, means it is not after using this air. In case of oil hydraulics, what is done, usually after the application we take back that oil to the reservoir, and before that we use the cooler. In that case, before utilization a cooler is used, but after cooler term is used after all process, that means drying etc. Then the cooling is done and finally it is used. Then air dryers, and we need indicators, that is pressure, temperature etc. wherever required. Also sometimes a set of pressure and indicator is kept to inspect the pressure and temperature at different point. That is sometimes needed, because there will be very big pipeline for the supply of the air pressure. Sometimes it is very difficult to find where the pressure drop, actual pressure drop is occurring. So, for that purpose we need a separate unit, pressure and temperature indicator. Now, we will come to these components. What are the components? And the most important is the compressor. Now, if you look into the types of compressor, then most common is the reciprocating piston compressor, and then again the piston compressor and diaphragm compressor. Diaphragm compressor means, in that case a diaphragm is being moved by some means, and that also compresses the air. And then rotary piston compressor, this is sliding vane rotary compressor. You see, one is that rotary piston and another is called rotating piston. Anyway, rotary piston means usually a volume is trapped and then that is compressed by compressing the variable area. In case of reciprocating, normally the stroke length varies, area does not vary. Whereas, in case of rotary pistons, you will find area is varying, say gear pump, like that lobe pump, etc. Then this rotary compressor, again sliding vane rotary compressor, 2 axle screw compressor, say like gears and etc., that also fall in this category, and roots blower. And then another, it is a flow compressor, that radial flow compressor, axial flow compressor, these are two different type of separate flow compressor, but we shall concentrate on, because these are the some special type, these are used for not normally such big system, very small systems these are used, but reciprocating piston compressor, this is very common, particularly piston type, and among the rotary pistons both sliding vane and 2 axle screw or the gear type compressor are mostly used. So, we shall concentrate on these items only. Now, reciprocating type, reciprocating cylindrical single piston cylinder type compressor may be of single or multiple. This means that it has meaning that single means, suppose there is a 2 pistons, that is not, that may not be 2 stage, only 2 pistons are being used and they are compressing the air at a same pressure. Whereas, you may find 2 pistons, but that is 2 stage, that means in first stage one piston is compressing the air and in second stage other piston they compressing that air. That means, suppose you have to raise the pressure up to 2 megapascal, first piston may be raising the pressure not exactly half, it might be 0.75 megapascals, and then second piston, that compressed air is being further energized to make the pressure 2 megapascals. So, that is called 2 stage. Similarly, there may have 3 stage also. So, we use single or multiple stage. Now, if I look into these figures, the left hand side, this figure A, that shows a reciprocating 2 stage compressor, but before that I would say that depending on pressure capacity, if the pressure capacity is 1 megapascal usually, in that case we can go for single stage. Then it is, if it is 3.5, then 2 stage, then if it is 17.5 megapascal, it is in the higher side. And as well we have to go for 3 stage, and for 35 megapascal this is 4 stage. Now, 35 megapascals means it is very high, this is definitely special applications Normally in case of fluid power we use normally 25, say 21 megapascal is equal to 3000 psi, 21. So, 35 means it is more than 4000 psi. Normally there is no such applications, but if it is required then we have to go for fourth stage, and normally reciprocating type is not suitable for that. Usually screw compressor is used for such compressions. Anyway, if we come to this compressing machines, what we find, here is one set of piston cylinder, here is another set of piston cylinder, and here this is the third. If you look into these two are identical, even they are having the same discharge valve, suction valve, these are same. Now, these two cylinders together pumping the air for the first stage, that means from the nature the air is being taken and that is being pumped, that is being compressed to reach a certain amount of pressure. Say for example, two stage mean this is 3.5, probably it is being raised up to 1.5 only. Then this total compressed air, now that total compressed air what the two piston has done, that volume has reduced, that for that only a single piston can pressurize that amount of air further to 3.5, and that is the second stage piston cylinder. Now, the other details you can study of your own from this figure. Okay. Now, if we look into this principle, you know it, but basic principle is that this while it is reciprocating, then there will be one is that delivery and one is the inlet and one is the delivery. Say it is rotating in this direction, so only the inlet port is open, and when it is rotating the other half, then it is being delivered. This is the simplest form of this reciprocating system, and the same thing is followed. Here just only suction and compression. So, in and out delivery. So, if you look in this way, for one cycle only suction, so half the cycle suction and half the cycle the delivery. So, you can put two cylinder single stage, but two cylinder in such a way that continuously it is supplying the air. Okay. To dissipate generated heat due to molecular reaction in the air being compressed, if you compress the air, you will find that heat is being generated. Cooling system, natural air draft to forced water cooling are employed. That means, for the small compressor you can simply use a fan just to cool, and this reservoir as well as the compressor outside is body is made with additional heat dissipation area. That means, fins are used, even if the tank you may find that additional fins may be used just to cool it. Okay. But for higher pressure, maybe say in case of 2 stage, 3 stage and 4 stage, you need to have forced cooling, and usually cooling by water is done. Other fluid can be used in case of say refrigerator systems. If some cooling is required, no water is used, but in case of general compressor, for big compressor which is used in industry, usually you will find the oil is being used. And normally if you look into these pistons outside, there are pockets. These pockets are filled with water. That means, water is always flowing through these pockets, that is called jacket. The piston is having the space through which the water is moving. That means, while it is being compressed, then itself it is being cooled to some extent, and after that also there is a separate cooler is used to cool the air. Now, this is a photographic view. I am not describing the components. You can understand this for the same machines. these two are for first stage and this is for the second stage. Usually a spring is provided just for the return stroke. If you look into the geometric of this crankshaft and other things, so you need to have some return. So, the springs are buffer springs are usually used. And if you look into the capacity with a 0.54 meter cube capacity reservoir storage tank, you can understand this 0.54 meter cube. So, 1 meter cube is equal to how much? 1000 liter. And here 0.54 means half of that 500 liters, around 540 liters around the volume, and compressing capacity of 1.3 meter cube per minute. So, this is called compressing capacity, not the flow capacity. We should call compressing capacity. At 1.23 megapascals, power of the motor is 6.25 kilowatt typical. If you calculate this pressure into flow rate, it will not be 6.25, but usually efficiency of compressors is relatively poor. That is why at least you need 6.25 kilowatt typical. We will calculate the sizing of such an compressors. Now, an air compressor is usually made auto control to start, run, supply pressurized air as needed and stop when receiver is filled with maximum capacity, that is pressure, and be ready to start again when the pressure reaches at its lower limit. A few methods are employed for such control. Pressure switch control is one of them. Once a pressure is established after first startup, a starting unloader, look at this term, it is called starting unloader, is required to prevent the established air pressure from pushing back against the compressor, preventing it from coming up to speed. The meaning of this sentence is that you have compressed the air and the compressor is stopped. Now, if you look into this line from the where the rotating piston is compressing the air, from that point to compressor path is completely filled with pressurized pressure. Now, it is cut off from the reservoir. Reservoir is supplying the air, and that pressure when it is reduced, then the compressor has to start, but when the compressor is going to be start, the trapped air to that will create a problem to start off the compressor. So, you need to release that pressure within that short path, that is from the compressor head to the reservoir entry point, that is called starting unloader. Now, we use here the pressure switch type. Now, if we look into this figure 4, this is the pressure switch. What is if you look into this is the compressor head, say air inlet is here. Now, this air is going and here is a non-return valve connected to the reservoir receiver, and then air is being compressed and forced with force, it is being entered into the reservoir. Say it is 2 megapascal. Now, when such pressure is this is reservoir is being filled, then with a set pressure this switch is there and that gradually disconnect the motor and your compressor will stop. But if you look into this path, then this path will remain filled with the pressurized air. Now, to relieve that, what is there with this pressure switch, there is a lever that operates another valve. Actually, there is another valve sort of things which allowed or relieve the compressed air between this path. Now, here apparently it is a open path, maybe here maybe some non return sort of valve might be there, which is not shown here. But what happens when this machine is stopped, the reservoir is having its maximum pressure, say 2 megapascal, then this motor is stopped, as well this path is made free, so that next time when the signal comes, it starts operating without any trouble. For that we need a unloader. So, this is you can say the starting unloader. When motor is off by pressure switch, it also bleed off. It is this operation is called bleed off the trapped air between the piston head and receiver's check valve. This is the receiver's check valve. It enables the compressor to start again whenever needed. Now, there is another type of unloader which is centrifugal type. The basic principle is that a centrifugal mass is attached to a rotating member. This is with the compressor crankshaft. Then when it reaches, then it operates the switch the same way the pressure switch operates. Now, in such a system, greater protection is ensured as the unloader valve is operated by the compressor itself rather than the pressure switch. Such normal controls described above are used where the compressor running time is 50% to 80% of total working time. Okay. Now, for the compressor starting frequently, say within every after 6 minutes, or running time exceeds 80% of total time, more sophisticated constant speed control is adopted. That is usually nowadays with electronics control, some controller is used to automatically cut off the compressor, start the compressor, and in between unload or the relieve the trapped air between the compressor head to the reservoir inlet. Okay. Now, this 6 minutes figure, what I understand, this is usually a figure, at least you should keep a 6 minutes time off between two running times, otherwise sufficient cooling will not be there. Now, we shall consider another type of compressor which is called screw compressor. Now, this is rotary positive displacement, because if this is like an hydraulic the screw pump, here also the two screws are rotating, but if you look into this might be rotating at, these two screws are rotating at the different speed, not at the same speed, and this is the entrapped volume is being compressed, it is taking in and it is going out in the other side. That means, inlet and outlet is usually axial in case of the screw type compressor. If we look into this figure, then we will look into this, it looks something like this. These two profiles are not same, I mean this profile and this profile are not same. Here is also, it is not very clear from this figure, but from the side view we can look into this. And what we find, then there is a timing gear, this is required for inlet outlet control. The cooling jackets is there, and this is not symmetric, asymmetric rotors, anti friction and rolling bearings are used in between. Okay. Now, this is the what is found, that this type of compressor is having much better life, and it can perform better in high pressure. So, you will find that of course, if you think in terms of volume, that will be less in comparison to the reciprocating type. So, where the moderate volume is required with very high pressure, maybe the screw compressor is better than the cylindrical piston type. As in screw type, the end-temp volume gradually squeezed to smaller and specialized volume for to be stored in reservoir. Usually it is axial. Usually you will find the axial inlet and the outlet in the radial directions, but at the other end, and these are the cooling jackets. Now, to assess and size of such a machine, 0.7 mega meter cube per second, that is the capacity of storing. 0.85 megapascal is typical for a single stage screw compressor. So, single stage screw compressor means it is not very high, 0.85 megapascals and 0.7 meter cube per second. So, this volume not that small in that way. Maybe this value may not be correct, I have to check it. 0.7 meter cube is a very big volume. Okay, then if we look into the side view of this screws compressor, as I told, these are not symmetric profiles. It looks like something like this. One is that thinner and another is wider, and here what we find, this we have 4 lobes, that means it might be 4 start screw, and here what we find 1, 2, 3, 4, 5, 6, here 4 and here 6. That is why you will find that these two are rotating at different speed, and we need a separate gear of the same ratio at the end just to match that. Now, you may ask why it is different. It is seen that this will give better performance as far the volume is concerned, and as this is being of different size, maybe to optimize the capacity, it is better. Suppose if we use here 4 and here 4, we may find that it is not the optimum design. Using 6 here, and because this is the main pocket, as if this pocket is being compressed by this is the piston. You can consider this is cylinder, this is piston. So, 4 piston is compressing the air within 6 cylinder, roughly you can say like that, but actual path is like that. It is a helical path through which the compressed air is being moved, separated by the contact at these two profiles and by the casing. It looks like Novikov gear. If you look into this side view, it looks like a gear, not exactly Novikov gears, it is different, but as if it looks like a gear. In fact, gear type compressor may be regarded as short screw compressor with different inlet outlet arrangement. Now, obviously, if you look into this, if you would like to compare with this gear this screw compressor with the gear type compressor, definitely this is also helical, that means helix gear as if, but this length of the screw conveyor, what is the length? In this case, length is very small. As well, you will find that inlet outlet is like that, but this is also of different profile, as you can see. You can compare this, but remember this one is the gear type, or sometimes it is called lobe type, and whereas this is the cross section of the screw type compressor. Now, here again I have shown some, say this is gear type and similar is the lobe type, but in case of lobe type usually these profiles are same, both the profiles are same and number of lobes will be same, but basic principle this lobes and gear are the same principle and you will find inlet outlet is like that. But remember, like the gear pump, this is, say suppose this is rotating in this directions, then this will be inlet and this will be outlet. Normally if it is rotating like in this directions, then people confuses, perhaps air is flowing like this in case of gear pump also, but it is not like that. The air is coming in, then it is being trapped and it is going out. If we recall that comparing with the gear pump, here from this contact point and these 3 contact line or point on this plane, if we consider with the rotation, this area will be gradually it will reduce, that means this volume will be compressed. So, this compressed air will now go inside, it will be trapped and then it will be delivered in the other sides, and this is the side view of this lobe type compressor. Inlet outlet as different, this is completely radial. In case of screw type you will find this is going like this and probably outlet will be like this. So, the length to be considered as a width of the gear in this case. Also the teeth may be straight and not helical. Say here somewhat it is helical, one can use the straight teeth for the gear type compressor, and lobes are always mostly you will find maybe straight also. Here of course, it is showing that as if it is helical, it might be straight also. In this lobe there is no space within the lobe, but here this space is given. It might be this is all can be used for cooling purpose also. However, capacity wise the screw type is superior, although has more friction. Losses due to friction are minimized using liquid lubricant, which also carry heat as well as mixed with the compressed and pre-filtered air. Now, in such compressor you have to lubricate this. So, that lubricant is mixed with the air. So, it might be we have to first demoisturize the air before entering into such compressor, and then or else the oil being mixed, that will not be separated. We have to use the separator or filter in such a way the oils are not being separated, because the oil mixing is being to some extent is being done while it is being compressed. Now, this is another view of the lobe type, and this is the constructional feature. You can see in this case lobes are straight here, as you can see, and you can see these operations, how these operations is being done gradually 1, 2, 3, 4, 5. These are the 5 stage of operations. I think you can study yourself. Now, next one is the vent type compressor. In vent type compressor, this is the principle is exactly same as what is in hydraulic machines, oil hydraulic machines. Now, this is a typical capacity 2.5 meter cube per second. This is very high, and 0.35 megapascal in single stage. Now, if you look into this, these veins are not placed exactly radial. you will find that is inclined. This inclination is given is like that. For this compressor you will find this is rotating in this directions, not in this directions. So that this is having the sealing effect, better sealing effect. Okay. If we rotate in this direction, the pressurized oil will put the pressure and to allow it to go inside, and so there will be leakage through this. Looking into this vane orientations, you can find that this is the direction of rotation. That means, from this side it will rotate in the anti-clockwise directions. This you can see how much this inclination is there, and this is the constructional feature of the vane type compressor. And also, if you look into this, in this case of course, the vanes are straight, but this is on what is that, there is a this is shown that how the thrust pin are provided, and then this is the packing strip, this is the rotor, and there is the slot, vanes, etc. This is a functional feature. Maybe this is also the straight type vanes are used. Here also, as we find, the vanes are straight. Now, if we look into the compressor rating, the rating of compressor is usually expressed as its storage flow in rate capacity of free air, that is at atmospheric pressure, that is 0.101 megapascal absolute, 14.7 psi, and temperature is 20 degrees Celsius. Sorry, spelling mistake is there. The flow rate is then called standard flow rate and usually expressed in meter cube per second. So, this means that intake volume we call in meter cube per seconds. Okay, this that volume what we have the mention in the capacity, that is the intake volume to the machine. So, 2.5 meter cube per second is the intake volume per seconds. Now, this gas law is known to you. So, we can use this gas law to calculate the rating of the compressors. V, P and T are the indicate the volume, pressure and temperature respectively, and subscript 1 and 2 represent compressors inlet and outlet parameters. Dividing both sides by time q, we get in terms of the flow rate. Now, if we consider a problem, a typical numerical example, in a large scale system, the air is used at a rate of 0.0142 meter cube per second at 0.875 megapascal and 32.22 degrees Celsius. Celsius spelling will be S, not C. Anyway, this is now this rate, if you look into this rate, is the delivery rate, utilization rate, not the compressor's rate. Now, we have to estimate the free airflow capacity of the compressors. In that case, the solution is like that. In these equations, what we put, that is the Q 2 is given, that is the utilization side, that is the outlet of the compressor. So, Q 2 is this mass and pressure P 2. Now, this pressure, whatever pressure is given here, mind it, we have to convert it into the absolute. That means, you add simply the normal absolute pressure. So, and then the temperature is, we have to add 273, that is the reference temperature, we have to add this, and then this to T1 and T2, temperature rise is from 21.11 to 32.22, and what we find that 0.132 meter cube per second of free air we need to compress. So, note absolute temperature is taken as 273 degrees Celsius, and this means that in order to have an air of 0.875 megapascals at 32.22 degrees Celsius at a rate of 0.0142 meter cube per second by the reservoir of a compressor, it needs a supply of 0.132 meter cube per second at 0.101 megapascal and 21.11 degree Celsius. Apart from the storage of air reservoir, that is storage tank of a compressor, dampen the pressure fluctuation and supply the pressure to utilization ends at constant pressure. In many cases, among all pneumatic system at the utilization end, a few may demand the higher flow rate at starting, which exceeds the capacity of the compressor. A well designed reservoir is capable of handling such transient situations. That means, time to time we need more excess air to flow. A reservoir size is expressed. Now, we have to also, depending on the plant, we have to find out the reservoir size. This is expressed by this formula, and where you will find T is the time that the receiver can supply required amount of air, and then QR is the consumption rate of the pneumatic system, QC is the output flow rate of the compressor, and P max is the maximum pressure level in receiver, and P mean minimum pressure level in receiver, and VR is the receiver size. So, again we consider another problem, calculate the required size of a reservoir for a system consuming 0.1 meter cube per second standard for 6 minutes between a pressure limits 0.7 megapascal and 0.56 megapascal before the compressor resumes operations. That means, this is the maximum limit where the compressor will be stopped, and this is the minimum limit when again the compressor will start. What size is required if the compressor has to run and deliver air at 0.002 meter cube per second standard? Now, simply in this to calculate the where we consider this is the pressure and this is the 6 minutes time, means this is in second, and this is the difference of this pressure here, and this is the difference in the capacity, flow capacity. So, what we find that we need the reservoir capacity of 2.6 meter cube at least, but here we have simplified the problem to arrive into this say formulation. This requirement is this, you have to exercise that really you have to make the average of total utilization, compressor time, how much it should be stopped, etc. So, that becomes a little complicated, not this simple, but for as a numerical example, this is the way how to calculate the capacity of a compressor. Size of the reservoir, pressure at numerator and denominator have the same unit. That means, in this case you should take care that this should be same unit, even if the pressure is expressed here in PSI, that is not a problem, this and this. And in case of B, as you can see that this is the meter cube per second, the standard supply. So, for that we need 0.208 meter cube. Suppose this amount of flow as intake is provided, then we can reduce the capacity of the reservoir. Generally, in selection of a reservoir tank, size 50% oversize is recommended, considering 25% for overload and 25% for an expansion if needed in future. Say for you are designing a such an compressor and reservoir for an industry, then in that case first of all you have to consider at least 25% overload may be there. So, 75% directly coming over there, and usually what happens after setting up, you may need to add 1 or 2 more equipment with that. So, another 25%, that means whatever capacity is wanted for an industry, usually if it is in the beginning stage, considering that is the 50% requirement, we usually consider 100%, and then we design the compressor. Now, power required to drive the compressor, a semi empirical formula is usually used in recommending actual motor size, compressor efficiency to be considered. Okay. Then this is the semi empirical relation to calculate the power, where P this is for the total of the motor, and then this is ideal. So, we are calculating the ideal one, and then we divide it by the efficiency, overall efficiency, to calculate the power, and Q is the flow rate standard, and P in is the inlet atmospheric pressure in pascals, and P out is the outlet pressure in pascals in absolute, and this is the overall efficiency. And again, if we consider another problem, determine the motor power required to drive a compressor having overall efficiency is equal to 75%, that delivering 0.447 meter cube per second at a pressure of 0.7 megapascals. So, these are the given data. Considering this, we can calculate this power ideal is coming 13.3 kilowatt, and the efficiency is 0.75. So, 17.73. So, we recommend a motor of 18 kilowatt. I think we can continue these components in the next lectures. So, now this is main portion of this is a book. This is available in Prentice Hall, Indian book. I do not know whether the print is still available or this is available in the market, but this is very good book to have some basic knowledge about the pneumatics. Also, there is another book that is by Wiley India Publications, and also this is Prentice Hall of India. But some practical application, the second book is good, and for basic knowledge the first one is very good. So, thank you.